Hi, hi guys. My name is Simon Jasper. I'm from CSE department. My topic for AIT for design and analysis of algorithms is on software and dependencies in research citation graphs. Introduction. In modern research, software plays a critical role in data collection, processing, simulation, and analysis. Most scientific results today rely on multiple software tools and libraries. Currently, in this modern world, we have a lot of software tools, and not only software tools and software models which can detect the graphs such as nodes and the vertices, the distance from one place to another. For example, Google Maps. There are a lot of tools in this modern world. However, traditional citation systems mainly focus on citing research papers and often ignore software and dependencies. Usually, in traditional research, they all used to rely on research papers and on theories, not on the accurate information that we have in this modern world. However, this creates gaps in reproducibility, transparency, and proper credit to software developers. That's why I tried to say earlier that the traditional methods may vary in precision, and there won't be any transparency between the actual data and the original data. So there will be a lot of difference when uh, issuing the distances between two nodes or two edges. That's how it is. Research citation graphs that include software and dependencies help overcome these issues. So, like these traditional research citation systems, they also uh, creates a gap between software developers. There won't be any credit given to software developers sometimes. Research citation graphs provide a structured way to analyze relationships between research outputs. Extending these graphs to include software and dependencies allows a deeper understanding of how research is conducted. It improves reproducibility, and also not only that, it ensures proper credit to software developments. In this modern world, we have actual correct data in the example distance between two nodes. Not only that, these traditional methods through research papers gives few more additional points and few more accurate data and proper credit to software developments in another point of view. Let's look into what research citation graphs represent about itself. It represents nodes and edges. We all know what node and edges is. Node is a point where it acts like a place. Edges, it acts like a distance between one node and the other node. For example, one node we can take is our college, and the another node we can take is the MLRIT, which is in the Gandham Vaisama Medchal area. So these two are the two nodes. The distance between them is known as an edge. That's what it is. Nodes represent here in research citation graphs. Nodes represent research papers, software, datasets, authors, or institutions. Edges represent station relationships, usage links, or dependency connection. Initially, citation graphs were limited to paper citations. However, modern research workflow require extending these graphs to include non-traditional research outputs such as software and data. We have three types of citation graphs. One is paper citation, which is used for impact factor, H-index, and ranking systems. This paper citation graph mainly focused on paper-to-paper citation. And the next one, software citation graphs. It is focused on software reuse and software impact. And the last and not the least, heterogeneous citation graphs, which combines paper, software, datasets, and authors. Properties of citation graphs. These are the properties. It is directed graph. It is only directed from one place to another, and is not unidirectional, only one direction. and it is most cyclic. Cyclics are rare and is also weighted, and weighted in the sense distance between the one node and the other node. Temporal nature, which where nodes and edges evolve over time. The process that is involved in the research citation graphs is we collect metadata from digital libraries and we identify the relations between citations and extracting software usage and linking entities using persistent identifiers. And this construction enables automatic analysis and visualization. Applications. We have a lot of applications of this research citation graphs. For example, we use this research citation graphs for measuring research impact and influence. Research papers often influence others to contribute to the research that is been happening at the time, and not only that, it also creates an impact on the current world, such as evolving ideas and making the people's mind a better and make them ideas pop into the mind. In that way, the research papers they always and often impact and influence others for making themselves to involve in a research that has been happening. Not only that, it is also important for discovering and foundational works. And not only that, it is identifying collaboration patterns, such as in this research citation graphs, they have few patterns which take repeatedly. They often repeatedly happen every single time, and tracking software and dependency usage, and also improving reproducibility and transparency. Research papers they are clear and structured and they are transparent, which gives an accurate and structured data to go forward and execute the information that is being presented in the research paper or research citation graphs. Software dependencies in research citation graphs. We have a lot of uh, softwares which represent citation graphs. For first and foremost thing, graph theoretic foundation. In this theory, we have a set of vertices, set of graphs, set of vertices, set of edges. For example, paper A and paper B. Paper A. Paper B means paper B means A cities B. Paper A. Software S means A uses software S. Software S. Library L means depends on L. Number two, mathematical representation. Adjacency matrix. Graphs are always are represented in two types of matrices: adjacency matrix and incidency matrix. Adjacency matrix they done on the are done on node basis. From I to J, I to I to K in that basis. Challenges. We have a lot of challenges in the citation graphs. First and foremost thing, lack of standard software citation. Yeah, the technology is being evolving in a broad way, but the software that we use for the citation graphs or the graphs, it's very minute or very small small in tech when we compare to the broad tech we are evolving in this current um, modern world. So, lack of standard software. One of the major challenges is the absence of universally accepted standards for citing graphs. Unlike research papers, which follow well defined citation formats, software citation practices vary across journals and disciplines. Complex and deep dependency trees. Research software often relies on a large number of direct and transparative dependencies. These dependency trees can become extremely deep and complex, making it difficult to track all contributing components. Versioning and evolution of software. Software evolves rapidly with frequent updates, patches, and version changes. Different research paper may use different versions of the same software, each with different dependencies. We live in a twilight world where people write the many research papers. We on Earth we have 7 billion people. They majority of them write research papers. So like I said, Many people write these research papers and many people read these research papers. So one are enthusiast on reading the research papers, and they think of writing. So many research papers are is being produced, so many updates need to be done, and sometimes the research papers may be wrong in sometimes, but also accurate. But in this software we need to update every single thing, that it takes time, and it takes a lot of cost to implement the software updates and deploy the software that we have programmed, and many more. Tools. Software Heritage is a global initiative to achieve, preserve, and reference. Citation.cff. It is a standard and machine readable file to specify how software should be citizen. Graph analysis tool. These tools help build, visualize, analyze research citation graphs. For example, Neo4j, it is a software which is used to given relationship between cities, between node and edges. And we have the another one, Jeffrey, which is a desktop tool for network visualizers and analysis. Here is the workflow of how the research paper citation graphs is being done. Thank you.